Okay, we'll solve quiz 3 for mechanical engineering statics, which is MENG1230 at Dunwoody. So we're given two vectors. We have vector A, which is 40i, 30j, negative 40k. There we are. And vector B, which is negative 30i, 20j, plus 30k. We're asked to find the dot product. Gets us 3 points. The angle between the vectors A and B, which I'm calling theta AB, that gets us another 3 points. Adding vectors A and B, and then the magnitude of that resultant. And then as a total, a little extra credit if you had time, you could find the coordinate direction angles alpha, beta, and gamma for our resultant vector. So starting with the dot product, we're going to take each of the I terms, multiply them together, add them with the sum or the product of the j terms, finally the product of the k terms, add all those together. So we start with 40 times negative 30. We have A dot B equals 40 times negative 30 plus 30 is 20 plus negative 40 times 30. So I'm just taking each of these terms times their corresponding term over here. So I get negative 1200 plus 600 minus 1200. That gets us negative 1800 for A dot B. Alright, so there's that bit. Secondly, now we're looking for the angle between the two vectors. So we also know that the A dot B equals the magnitude of A times the magnitude of B times the cosine of theta AB. So negative 1800 equals, now we need to find the magnitude of these guys. So it's going to be the square root 40 squared plus 30 squared plus negative 40 squared times square root of negative 30 squared plus 20 squared plus 30 squared. So just squaring each of these terms, adding them up, multiplying by each of these terms squared, taking the square root of each of those, product of those, then cosine theta AB. So when I put that through, this part becomes 64.03. This part becomes 46.90. And this is still cosine theta AB. So theta AB is the arc cosine, negative 1800, or 64.03 times 46.9. So that gets us 126.8 degrees, which goes to three significant figures is 127 degrees. Alright, finally adding the two vectors FR, A plus B. So now instead of multiplying our I and J components like we did for the dot product, we're just going to add them together. So we have plus 40, negative 30, plus 30, plus 20, negative 40, plus 30. So our first term is going to be 10, second term is going to be 50, our third term is going to be negative 10. So we're going to have 40 minus 30 I hat plus 30 plus 20 j hat plus negative 40 plus 30 k hat. So that equals 10i plus 50j minus 10k. Alright, and then we're asked for the magnitude of FR. It's going to be the square root of each of these terms squared. So we get 10 squared plus 50 squared plus negative 10 squared. So it's going to get us 51.96, which to three significant figures, FR 52.0. Alright, then finally, if we had a little extra time, we could find the coordinate direction angles. Alpha is the arc cosine of our I component over our magnitude, 10 over 51.96. Beta, arc cosine of our j component over our magnitude, so 50 over 51.96. And gamma, arc cosine of our k component, negative 10 over magnitude 51.96. So I got 78.9 degrees, 15.8 degrees, and 101 degrees. So that gets us our alpha, beta, gamma. And that was for extra credit. Just some practice doing our dot product, using that dot product to find an angle, little vector addition, and resultant magnitude calculation.